Today I want to get started on hooking up the speedometer. So one of the problems with this transmission is it has no speedometer output at all. When they use it in the Jaguar has a magnetic sensor in the rear end, and in the Land Rover, I'm going to guess it's on the other side of the transfer housing, because otherwise it would be off by 50% when you went into low gear. So, and I didn't see any way to add one. There wasn't. I mean, an awful lot of this thing you can see where they make it different ways and there's provisions for different things, but I didn't see anything for that. So we picked up a Dakoda Digital Speedometer drive, which is essentially electric motor and a mount somewhere other than down here, and that picks up a signal from a magnetic sensor. So for the magnetic sensor, I picked up it's a conversion kit apparently for an automatic speed control, and it essentially is a bracket, a coil, and some magnets that go on the drive shaft. So I've decided to mount them on this front yoke just because it's close to this bracket which I intend to use. This is the bracket that was in the car, and it means also that there'll be less centrifugal force on these that's smaller around. So my intention is, the kit just gives you a zip tie and says, you know, put the magnets on here, put the zip tie around and trim it and walk away. And I suppose that's okay, but you know, I've had lots of problems with zip ties over the years, that they deteriorate, they fall apart. I mean, I suppose a typical car that people buy, they're going to put that in, they're going to have it for a couple of years, and then they get rid of the car. Well, this one's probably going to be in here longer than that. So, what I want to do is I'm going to put a little dab of epoxy on the back of the magnets when we place them, and because of that, cleaned up the yoke. So you can see it's nice and shiny because I got started already. I just took some of this emery cloth, put it around the drive shaft, a bit of that, and just rotated the drive shaft a bit so I can clean all the way around it. Like that, and it cleans up pretty well. And once you've done that, of course, this is just a rag with some lacquer thinner on it, and just clean it up and get it all nice and prepped. Just like that. So I think that's ready. I want to have to get set up for the epoxy, so I will go get ready for that. I was just thinking about, I don't know how sensitive the reader is going to be to the spacing on these magnets, so I thought I'd just try to get them spaced as well as I could. So I've put a mark on the drive shaft with a pen. I'll put that up sideways. These are machinist calipers, and this tells me approximately where 180 degrees is out, because they're set to be a few thousandths smaller than the shaft. So just mark that. That came out. Here's another mark. And then get those. So they're level. So I'm really just doing by eye, but seeing that this is pointed straight down. So that tells me that's the third position. And I'll turn this one more time. Put the caliper on the mark. And it's right there. So I'm sure they're off by maybe 1/8 of an inch or so, but I think it's pretty close. And there's no instructions, because the instructions for this part are for the cruise control, and of course the instructions from the Dakoda speed reader assumes that you have an American car, and they make a piece that screws into where the old transmission cable went in, and that has a magnetic pickup in it. So, you know, I'm just kind of haven't got any information on this. I'm just kind of going as I go. So I'm just going to go with 4 placed like this. So I've made a further refinement in my method. I held the pen up, spun the drive shaft, give myself a line so they all line up. That was easy enough. And I just thought, I got a pair of these are tools to use on the lathe, but I could set this to this gap and went all the way around. I knew I was pretty close, so I had to adjust this 3 or 4 times, and 3 or 4 times around on the drive shaft, but I finally got the measurement where all those line up equally, or within 5 or 10 thousandths, which ought to be plenty. So I've now gone and I've scribed a couple of marks onto the drive shaft. You probably can't see them, but there's just a little line emanating from the corner of each magnet. So I'm going to have to take the magnet off and put a drop of epoxy on. And then I can put them back, and then when I go to set the next one, I can double check my measurement with these. So that seems pretty straightforward. So I'm going to go ahead and start working on that. And I'll probably take because I'm not doing this for entertainment and in education and not as an insomnia cure. I'm going to shut off the camera for a minute, and then we'll show you when we go to put the last one on. Okay, so we got the 4 magnets stuck on. We'll just check the alignment. Make sure they're centered on that line. Pretty square. I think we're good. The only thing left to do is to put the zip tie on. The problem is that when you try to move the magnet, there's no guarantee that the zip tie or the magnet you're moving is the one that's going to shift. Well, I think that's got it. So we'll leave that be. And I think it's time for lunch, so we'll let the epoxy cure and come back and look at it later. I've mounted the new bracket. I have to drill an additional hole in the piece of steel because it was blank here, and that's just a 1/4 inch 20 thread bolt going through the existing bracket in the slot, and it's got a nylock on the back side and a washer. And then I drilled the 3/16 hole here, and this is one of the screws that was supplied with the equipment, and it's a sheet metal screw, so that just went in, and that's got that nice and tight. So it'll vibrate a little bit, but there's supposed to be a 3/4 of an inch clearance, plus or minus a 1/4. So any small vibration there I don't think is a big deal. I suppose if you really wanted to get fancy, you could take a small piece of angle iron, bolt it on down here, and that would really rigid this up. But and I might do that, but let's see where the sensor winds up first. This is the sensor here. This side will go towards the drive shaft. This is the bolt they supplied to secure it. This is the nut that they sent. This is a piece of stamped sheet metal, so that's a piece of junk. So I got another nylock for that. So if I put a piece of angle iron on, I'll drill it and put it through this and through the 2 mounting holes. And here's the finished installation. I found a little piece of C-channel laying around the garage, so I used that as a strengthener, and you can see that really ridged this up. This thing used to be like a little springboard. Got about a 1/2 inch clearance. You know, eventually we'll run the wires back here. This is where everything comes through on this car now. It'll probably pop out through there somewhere, or I don't know. We'll find somewhere to run all this stuff anyway. But that looks like that'll do today. There's the sensor on the end. It's kind of hard to see because it's black. So I've put the wires from the sensor inside of this black flex conduit. You know, it's slid all the way down the end just to neaten it up. Put it through the transmission mount to keep it in place. I caught a body mount there, and then it's going up here. I'm not really sure you can see this, but it's going through a hole in the transmission tunnel where the speedometer cable was. So I just ran a piece of an electrical fishing wire. It's just a piece of springy steel into the conduit, and then taped it up, pushed that through, came through beside the speedometer cable, and they could see it. It actually pushed it in 4 or 5 inches. It wound up over by my steering column. It was a lot easier to find than I thought it would be, and just pulled it on all up and through. So I've got that there, and we'll have to show you the mounting for the box and show you the other wires. This cable is not going to work for my installation. One, it's too short, and it's also set up for a push-on type speedometer, which when I have a threaded one, thought I'd ordered one with the standard GM thread, but apparently either I didn't or they sent me something different, and regardless, would have certainly had to reroute this at a bare minimum. This would not have gone through the transmission tunnel. So what I'm going to try and do is to take this end off, which is the end that goes into the Dakoda counter, and try to install it onto my original cable. So the other cable, I can just cut it off because I'm not worried about it, but I can't do that here because I need to keep this piece, but I don't care about the flexible shaft. So here goes trial 1. Let's see if it'll just push off with this. This is actually a tool for removing door panels and stuff. It's designed to go under the panel, over the door, and behind the spring clip and push it out. But it's just handy size to reach into here. I'm not sure if I'm going to get the kind of leverage that I need. Well, maybe so. That definitely seems to be moving. Can't really see it, I suppose, from that camera handle, but that just moved out about a 1/4 inch. So let's try that again. Oh yeah. Look at that. Click. So before I did that, I did take some dimensions to say how far the center cable was sticking through. What I'm going to do now is I'm going to go see if I can't find something round like a punch. So you can see this is dimpled on. If I can drive it through here to expand those out again, so that when I put this onto the new cable, I can crimp it again. So you can see that came off. It didn't bother that at all. I'm really surprised. This is an all plastic cable. The cables that I have, I think they have plastic liners, but they have a coiled, almost like a spring out of flat metal. That's the main part. So I found a punch that fits that pretty well. I want to try going from this way because I really don't want to collapse this bell. So this will just be a straight shot, so I'm thinking it's a lot stronger in that direction. Through pretty readily. Can I get it off again? I guess that's the next question. Again, I want want to be careful here. There we go. So let's knock that back through. I suppose the problem is this isn't really long enough to get all the way through here, so I think I'll see if I don't have a longer one of these in the garage. These are just the short set that I keep out here by the lift. So, much longer one here. That first one went through that first set, but it didn't really go through the second one. So, push this on through. There we go, we're all the way out flush. Not sure you'll be able to see through that, but did a pretty good job of pushing those back out. I'm sure they're still dimpled a little bit, but they ought to go onto the other cable a lot easier now. Well, I'm going to try and be lazy. So I'm going to try the same trick. This is the end of the original cable, so a couple of vice grips to hold the cable, being careful not to crimp them too hard so I don't want to collapse it, and just the same thing we did in the vise to see if it'll move. Well, it looks like it moved a little bit. This one feels a lot tighter than the other one. No, there it goes. Look at that. Yeah, voila. Removed. So the other thing I need to look at, I think I should take care of it while everything's out of the way, is this square seems to be slightly bigger than the square on the other cable. So when I put it into the drive unit, this is the drive unit here, by the way, I'll give you a better shot later. It doesn't go in far enough. The receiver seems to be tapered. So I'm going to compare the two cable ends, and I'm thinking that my Dremel tool will probably shave it down a little bit so it fits better. So we're going to give that a whirl. So I ground on this for a while. You can see it's actually an inner and an outer cable, or inner cable and an outer cable. So it got so thin that some of that inner cable was exposed, but it's actually back here that it engages in the boss in there. So this is about as much as I want to trim it. Where I stopped grinding is where the cable had not been squared, because they square it by pressing it, like in a 4-job vise or something like that. Anyway, so it looks like if I put this on and I don't go quite the full engagement, maybe stay up 3/16 or something, then there ought to be a little bit of slack, so this isn't driven hard into that, because that would wear the bushings in that and can cause your speedometer cable to jump and all that. So it's just a matter of putting this piece on now and then crimping it. So I'm going to install this now. This is actually a cable TV tool. This is for putting the ends on the cable. I bought this when we bought the house because I ran a whole bunch of cable underneath the house at one point in time. But it looks like it'll work on there. And it might be like one size smaller, but I'm guessing this is such a thin piece of metal that it'll probably work just fine. So anyway, we're going to give it a try. So we'll put this on. So you won't be able to see that, but the top of the cable is about there. About 3/16 down. And as you can see, it projects past the end of this, so it should be engaging all right. Let's see how this crimp works. It'll work better in the big one. That's where I want it to be. Wow. Well, I got the jaws to close against each other twice. The original one had 2 sets of crimps, and that looks like that's on there pretty well now. And that looks good. So there's the motor. And what it did is, there's a brother to that screw down here, so I took it out. I put a slightly longer screw in with a couple of washers. I drilled these 2 in. This is obviously the heater box. This is where the fan is, and this is the duct for the air to push it through the cores. So the air conditioning core and then the heater core. So I was really careful. I'm pretty sure there's a couple of inches of clearance in here, but I just drilled really easy, made sure the drill didn't go sliding through when I got to the end. I took a small piece of wire and put it in, make sure it wasn't anything I was running into before I put these screws in. So the last thing I wanted to do was drive a screw through one of the heater or air conditioning cores, because having this box out, which I took out 2 years ago, is a huge pain. I mean, I guess you don't have to take the dash out, but you take out all this cowling, the windshield wipers, you have to take hold the hood way up out of the way, and then get it out. The problem I had was all the vacuum lines, because this thing, it's climate control. There are literally a dozen vacuum lines coming in here to operate all the different servos and valves and stuff. And someone had cut them off, put a male-to-male plug in the end and stuffed it into the old ones. Well, the old vacuum lines in there weren't any better than the ones out here, so it just split them. So none of the vacuum was working. So I had to replace all those. The heater motor had a dead spot in it, which it stopped on, obviously. Murphy being Murphy. So I had to replace the heater blower motor. I replaced all the vacuum lines. All the foam seals and everything were just dust. So I went through and rebuilt all that. It's the same heater core and air conditioning core, but I looked at them. They seem to be okay, and we've since used the heater, and that works fine. The only thing that doesn't work so good is the heat control, and well, I suppose I've got this in the way now, but under here there's a vacuum controlled valve that turns the hot water on. I don't know if you can just see it under there. It's that sort of goldy shiny piece, which that's not original to the car either. But the problem is, inside the heater selector unit, there's a bleed valve, and when those things start leaking, because they've dried out, there's not really much you can do. The stags are same thing, and the only thing I do for the stag is basically block off all the bleed ports, so the vacuum would just stay on, because before it just leaked so bad. Anytime you went up any kind of a hill and the vacuum in the manifold dropped, it just turned the heat off, even though that there's an accumulator ball and all the rest of that. And what I did is I put on a vacuum valve in, which is basically just on and off, so it would turn the vacuum on, it turn the valve all the way on or all the way off, and that's just electrically operated. And I put that in to the dashboard in the Stag where the choke used to be, because the Stag's got a 4-barrel conversion, and that has an electric choke. So the only bad thing is that the heat's on all the way or it's off all the way. So if it's really cold or warm, you don't have a problem. That the only way you can really modulate it is to change the amount of mix air. So by having the fan off and then changing the fresh to, whether it's taking the air from inside or outside, if the fan's off, you're basically cutting down the airflow, so it's not bringing as much heat into the car. So it's not as good as having a temperature variable core, but at least you can turn it down. This car seems to be much the same condition at this point, that the heat either seems to be on or off, and being climate controlled, there's the piece that you set by hand, but there's also a bulb, a brass bulb in there that's got ether in it, that as the bulb gets warmer, it's supposed to turn the water flow down so that the air is at the optimum temperature. So you just put it to, in a modern car you say, I want it to be 68 degrees in here, and the computer takes care of it. Well, this was trying to do the same thing mechanically by adjusting how warm the air into the car was. So not a perfect system, but the problem is I'm probably worked great for the first 20, 25 years, but now those controls are just, all the rubber that's inside of them is all just deteriorated. They were never designed to be taken apart. You can't buy parts. You can't even buy, complete assemblies to rebuild into a larger assembly. That all you can do is buy a used one, which is probably just as bad. They tell me the one that's in the Stag they used in some of the XJ6s. I don't know that for sure. So at this point, I just do what I do. Of course, here in California, it doesn't get that cold anyway, so we just kind of deal with it. There it is. Anyway, so we've got the units in. The wires are run in. I've not wired it electrically yet. The speedometer cable is hooked up as the original cable with a new end into the original speedometer. The drive shaft sensor's in. So after we get this running, we can see if it works. And then this one is programmable. So I just looked at the directions quickly. There's 3 ways to set it. One is to drive a measured mile. Another is to go 20 miles an hour and tell it you're doing 20. And I think the other one's at 40, which I might do. I think my guess is that third gear in this transmission is direct drive, which was the same for third gear in that transmission. So if I put it into third instead of letting it go into overdrive, I do know that about 1,000 RPMs on the motor is about 20 miles per hour on the car when there wasn't too much load on it because of all the slip in the torque converter. So I'll probably, if it'll set at 40, I'll be able to get it on the lift, get going 2,000 RPMs, tell the computer that's 40 miles an hour, and that'll get me close. And then once somewhere, I know there's a couple of spots around here where they have permanently installed speed readers, so you could actually see you were doing 40 and tell it 40. We'll do that later. So this should, except for the adjustments and the small amount of wiring, I got to put a pair of 2-wire plugs onto this and the sensor. And then there's a push button wires in, and that's how you set the computer, and it gets power and a ground. So that should be it.